over here to another plane over there.
Okay, can we back up for some more general questions that have come up during the webinar?
Absolutely.
Okay, is there a Mac version of Grasshopper in the works?
That's difficult to answer. We're not writing code at the moment to have, no, wait, back up. I am not writing code for the Mac. It is our sincere hope that we can actually expose an SDK at some point which will allow plugins to run on both the Mac and Windows. So not just Grasshopper, but any plugin that's written in .NET should run on both platforms. And we are writing code, but we've only started just 1 week ago. It's a big project. It's going to take a while. And I have no idea when and if it will be finished. But we are very much trying to get this to work, so I think it's looking pretty good.
Okay, and next, could you ask David to talk more about the remote control panel and its application? Is that something you can give us a short answer for?
Well, I can talk about it, but it doesn't work at the moment.
Okay.
it's taken out a while ago. The basic idea is that in a remote control panel, you would have a comprehensive list of all the sliders and gradients and changeable things inside this network in one place. So you could hide this window and not see all this horrible wiring. And just have a clean, simple list of information in the property panel here. And just drag sliders here, change values here, change colors here, and it all updates at the same time. It used to be there a long time ago, but I took it out because it has to be improved, and I'm still not done with actually fixing it. So at the moment, it won't actually do anything at all. It's just a blank menu item.
Okay, let's go back to example 1. A question that came in when we went on to example 2 was how can we loft a surface on those arcs? Do you have a quick review of that for us?
I hope I still have the arcs here. Yes, there we are. So this file here is the one we used, but my curves are long gone because I overwrote the file. So I have to make some new curves here and rewire the inputs. So curve 1, curve 2, rewire the curve inputs. These are apparently, okay, I'm going to hide some of this stuff here because it's way too busy. So I'm going to hide these points, hide the lines, hide the midpoint, and hide the moved points. So we're just down to only arcs and only those base curves. Okay, it still works. We can still move this slider and actually have it update. Okay. What you have here is a list of arc curves. Right? So if I look at this with a text panel, I can drag in a text panel here and look at these arcs and see what they're actually all about. So I have a single list of arcs, and it tells me the radius of the arcs and the angle domain of each arc. And when I loft these arcs, it should just work out of the box. I mean, there's absolutely no reason why loft wouldn't be able to handle these kind of curves. So if I search for a loft component, I can type in loft, and it will actually find loft options right here. And the loft takes a bunch of section curves and loft options. My section curves are my arcs, so I can just share those. I can hide the arcs. This actually gives me the loft surface here, which of course still updates just fine when I change the slider. Let me also reduce the number of divisions because it's getting a bit much here. Let's go to 25. Both counts. Okay. Now it appears to be that there's actually not just one clean surface, but that there's a list of 4 surfaces from this loft. I'm not quite sure why that happened. It depends on the loft settings and the loft function we use. At some point you'll see it disappear and reappear. So it's a bit of a, well, it's the same thing in Rhino. Sometimes you loft and you get a poly service instead of a single nice service, and you have to merge services and all that stuff. So in the options, you can change all kinds of stuff. You can change if you want to close loft, or if you want to align them, or how you want them to fit the arcs. If you want to rebuild, that kind of stuff. It's all in here. It's the same as in Rhino. So if I rebuild, I get a single clean loft with 10 control points. Now, what would I? Never mind. Okay.
Can you show how to ungroup a selection?
Yes. If you group something, Control G, it generates this outline here, which allows you to move stuff in one go, and you can assign names to it, like make arcs and loft. So you can actually explain how what it is that you do over here. You can change the group outline by double-clicking it, so it goes from a rectangle to a metable outline. And you can remove a group by selecting it and pressing delete. So there's no ungroup command, it's just select the group and delete it. And that won't delete the objects inside that group.
Great, thank you. Can we go back to example 2? The question is, can you associate those circles with a NURB surface as a trimming boundary? That was your bitmap example.
I'm not quite sure what the question means. Am I asked to put these circles on a surface boundary, or what do you think, Mary? Okay. Cutting holes can actually be pretty tricky, and not to mention very, very slow. But I can show you how to map these things onto a surface, a freeform surface, which shouldn't be all that difficult, especially if we allow the circles to be deformed in UV space. So I can just make planes by hand in Rhino itself. I can say, I'll start with this plane over here, and make a second plane over here, and this one will be deformed. So I will take it, add some nice deformations to it, and refresh the shading mesh. Okay. So I'd like to take these circles and put them from this plane onto this plane. This is something that you'll find in the XForm tab. There is a bunch of components here that will allow you to actually morph stuff. So, for example, there is a let's see here, a surface morph. That sounds promising. Oh boy. So this is appears to be a pretty complicated piece of component here. It takes the geometry to the form, which has all our circles. It takes a reference box to map from. Okay. It takes a surface map onto, which is the one over here. And it takes a U, V, and W domains for the original mapping. Okay, well, it's not going to be that difficult. It's just going to be a lot of setting up. So I take all my circles. There will be a reference box to map from, and I'll just pick a box by hand. I can say it's over here. The box is defined locally. Our surface to map onto, I can specify through the menu here. So S set on surface, I can select it. And then there are U, V, and W extents. These are surface domains, and they will be NURB surface domains. So I will use the command in Rhino called reparameterize to make sure that the domain of this surface goes from 0 to 1 in both directions, just to keep it easy. Oh, sorry, I'm doing it wrong. 0 to 1, 0 to 1. Okay. This surface domain should now be 0 to 1 in U and V. Yes, there we are. It's 0 to 1 for U and 0 to 1 for V. So I can set my domains here to also be 0 to 1, 0 to 1 for U, and 0 to 1 for V. And the Z doesn't really matter much. It's because it's all flat. But now you have a mapping defined from a box space to a freeform surface space here. So all these circles are now actually morphed onto this freeform surface. And they will no longer be circles, they will now be curves because they're actually deformed instead of just moved and rotated. So especially over here you can see that this is now some kind of weird oval instead of a circle. So if you don't want that to happen, then you have to figure out a way to transform this circle base plane from over here to over there. Which is possible, it's not very difficult, but it will take another few minutes. So I think we're all drowning here, so I'll just move on to the next question.
Okay, the next question is in reference to example 3. How did you get the nice rainbow color in the previous example instead of a single shade of red? So the attendee was getting just solid red.
Solid red, yes. I think the reason that this failed is because of, let me put that geometry back in again. Okay, let's just go back to our original definition here. We went from green to, let's have this gradient up here, and we'll pick both objects. Okay, so this is what we have. And I'm guessing what you have is something that looks like this. Is that correct? That's probably correct. And the reason it did this is because this gradient has a numeric range to it. The first edge here, the green edge, is at location 0, which is this first input here. It's at 0. So if the distance is 0, it will become green. Now the right edge, the red edge, is at the second limit, which is number 1. So if the distance is 1, it will become red. As you'll see here, that almost every single distance is much larger than 1, which is why it just keeps on being red the whole time. If you change this limit to something else, you can scale your gradient. For example, I use a slider here from 0 to 50 to increase this gradient. And as I increase the length of the gradient, so does the previews change on the mesh itself. Now, of course, there are ways to actually make this smarter. Sometimes you don't know what sort of range you need here. So what we could have done was measure or find the lowest and the highest number in this list of distances, and actually assign our gradient based on that local range. So then it would always work just fine, no matter what we actually pick. But it's also possible that you want to have a range that is actually that means something. So when you have a range of 25, that's important that you know that there is a sharp split between left and right. So we go from green to red. We can have a gradient like this, which is a very, very sharp edge on it, where there's a color going into this grip and a different color coming out of the grip. And this will allow us to really accurately measure a sharp boundary for distances. So sometimes you want just general feedback, and sometimes these colors really mean something very, very specific, in which case you want to use numbers to make sure that your display is correct.
Okay, David, we are out of time. So do you have any last words for us?
Yes, I do. If you're not already logged into Grasshopper, I would advise you to do so now. So go to this forum here. It's a name forum. It's a fantastic place with lots of excellent questions, excellent answers. There's images, videos, tutorials, blogs, plugins, downloads. So all things Grasshopper are at this location. So please sign in and be sure to check our news there.